the name node manages the file system namespace, maps the file name to a set of blocks, and maps a block to the data node where the block resides. It also does cluster configuration management, and it has to handle the replication for each block, because each block is replicated 3 times, so it records the location of the copies of the block in case the block fails or is lost by one of the data nodes. So what kind of metadata it is that it stores? The list of the files. The file can be broken into one or more blocks. So the list of all the pieces of that file, or all the blocks that it is made of. Now these blocks can be in more than one data node. So in which data nodes are all the blocks? That's part of the metadata. And any of the attributes of the file, the user that owns it, the time it was last modified, the time it was created, the size of the file, the name of the file, and all that information is attributes of the file. Permissions, read, write, and execute for that file. And so it also holds a transaction log. So if anything was done on the files, it logs that here. So if anyone accessed it, created it, deleted it, or copied it, all of that is saved into a log file. So that's what the name node is doing, the master node. The data node, or the servant node, so to speak, is a block server. So it's a server. That's the node that serves the request. So it will store data in its local file system. Remember that that's a single machine that has its own hard drive. So it's just going to store the data on its local hard drive. And the metadata of the block. The metadata that we have just seen in the previous slide. Save the data and serves the data and the metadata to the client. So the client is invoked on behalf of the user, and it's going to contact this data node and request a file. So the data node is by the name of the file, which is in the metadata, is going to pull out the file from its hard drive and give it to the client. Block report sends a report to the name node of all existing blocks that it has, because the name node has to store the information about all the files and the pieces of the files and where they're located. If the data has to be transferred from one node to another, then this data node is responsible for doing that, to forward the data into other data nodes that are specified. As we mentioned, the block has 3 copies, usually, in case of failure. The first copy is on the local drive of the data node. The second copy is on a remote rack. And the third copy is also on the same remote rack. If we want to have more copies than that, they are randomly placed anywhere. Okay, so if one of the nodes fails and the block is lost, then we need to obtain the copy from the nearest node. How do we know that this data nodes failed? slide, you're going to see that this has a heartbeat to the name node. So we need to have a way of telling if these data nodes are alive or not. So periodically we make them to report to the name or master node if they're alive or not. And we want to do this once every 3 seconds. Just to make sure that all the data nodes are alive, and if not, to give us some time to obtain the block copies from another node. So that's called a heartbeat. So every 3 seconds, data nodes will send some signal to the name node to tell it that they're alive. And the name node or the master node is responsible for detecting if any of the data nodes failed. And it has to choose the new data node to store the copy of the file of the block that was lost. It also has to make decision how to balance the usage of the disk and the communication traffic to these nodes. So because the machines are connected through a network, we need to think of the amount of data or network traffic or bandwidth that we're sending between the machines, because that can be a real bottleneck with this type of distributed system. If we're sending too much data through the network, it's going to slow down the processing. We want to minimize that and do as much processing in the local machines rather than have to transfer files in between them all the time. Another problem with network is that the data that travels through the network can get errors in it for various reasons. Because let's say there is an interference, there is other cables in between, and then they cause some of the bits to be switched from a 0 to a 1, or from 1 to 0, and they're no longer correct when they arrive on the receiving side. So that we need to check, and we need some way of checking to make sure the data is correct. If it's not correct, it can either be resent, or we can try to fix it. And this thing right here, cyclic redundancy check code 32-bit word, is just an algorithm that adds redundancy to the data and allows us to follow certain steps that we can detect if there's an error and also correct the error by following these steps. So that's a checksum that when the file is created, we compute a checksum on every 512 bytes, and this checksum is stored at the data node, and then when the file is accessed and the client retrieves the data, it checks it, it computes the checksum and compares it against that. If the data is incorrect, if it has been damaged in transit or otherwise it has errors in it, then the client tries to obtain the other copies of the data. Okay, so we have been talking about this data nodes failing all the time, but we seem to have here a central point of failure. So data nodes can fail, okay? They say they contain our block pieces of all of our files. We have 3 copies of each. If one of them fails, hopefully the others are still alive. They are reporting to the master node every 3 seconds through this heartbeat. And what if the master node fails? What are we gonna do then? Are we just going to lose all the information for the entire directory tree on the cluster? Because that's what it contains.
There is a backup recovery Maybe from the remote node we can.
Okay, so somebody said backups. So we are going to create backup of that for just in case it fails, so we can restore it. Or we can try to have another copy of it and being replicated all times. Both of these are done. So we both make backups of it and have a replica of it. Although the replica performs other functions other than just waiting to be for the master node to fail.